Hello everyone. Welcome to another exciting lesson. Today we're diving into a fundamental force that shapes our world. Heat. Whether it's warming our homes, cooking our food, or even influencing the weather, understanding heat is crucial. In this video we'll explore what heat really is, how it moves around, and why it matters in our everyday lives. So, let's jump right in and explore the fascinating world of heat. Have you ever wondered why a cup of hot cocoa cools down over time? Do you know why wearing dark clothes on a sunny day can make you feel warmer? Have you thought about why the sand at the beach feels hotter under your feet than the water? How do we know whether an object is hot or cold? We'll seek answers to all these questions in this chapter that is heat. Hot. Hot refers to something that has a high temperature. When you touch something hot like a stove or a cup of hot water, you can feel the warmth. Hot things can sometimes burn or cause discomfort if touched for too long. Cold. Cold is the opposite of hot. It refers to something that has a low temperature. Ice cubes in a freezer or a cold drink from the refrigerator are examples of cold things. When you touch something cold, it can make you feel chilly or give you goosebumps. You might have heard in the news and by your parents that today temperature is low or high. What's this temperature? How to measure it? Let's look into detail. Temperature. Temperature is a measure of how hot or cold something is. It tells us how much heat energy an object or substance has. We measure temperature using a scale, such as Celsius, degree C, or Fahrenheit, degree F. Thermometer. A thermometer is a device used to measure temperature. It consists of a narrow, sealed glass tube with a bulb at one end that contains a special liquid, like mercury or alcohol. When the temperature changes, the liquid expands or contracts, moving up or down the tube. Key points. Measuring temperature. Thermometers have markings indicating different temperatures. We read the temperature where the liquid level stops. Units. Common units of temperature are Celsius, used worldwide, and Fahrenheit, mainly used in the United States. Applications. Thermometers are used in weather forecasting, cooking, medicine to check body temperature, and in various scientific experiments. There are two types of thermometers. First is clinical thermometers. A clinical thermometer is a specialized thermometer used to measure human body temperature accurately. Unlike regular thermometers used for measuring air or water temperature, clinical thermometers are designed to measure the temperature inside the human body. Features. Design. It has a long, narrow glass tube with a bulb at one end that contains mercury or alcohol. Range. The scale on a clinical thermometer typically ranges from 35 degrees Celsius to 42 degrees Celsius, or 95 degrees Fahrenheit to 108 degrees Fahrenheit. Accuracy. It is calibrated to be very precise, usually with markings every 0.1 degree. Safety. The tip of a clinical thermometer is usually blunt to prevent injury, and is designed for oral, rectal, or underarm use. Usage. It is commonly used in medical settings by doctors and nurses to check for fever, which is an indication of illness or infection. Let's see how to use. Shake. Shake the thermometer to bring the mercury or alcohol down to below the scale. Placement. Place the thermometer under the tongue, in the armpit, or rectally. Rectal thermometers are different and often have a shorter tip. Wait. Hold it in place until it beeps or for a specified time, usually about a minute. Read. Remove and read the temperature by looking at the level of the mercury or alcohol inside the scale. Importance. Clinical thermometers help healthcare professionals monitor patients' health by accurately measuring body temperature, which is a crucial indicator of illness or infection. They are essential tools for diagnosing and treating various medical conditions. Monitoring body temperature with clinical thermometers can aid in identifying contagious individuals who may be spreading infections such as flu or COVID-19. Second type is laboratory thermometer. A laboratory thermometer is a specialized thermometer used in scientific experiments in laboratories to measure temperature with high accuracy. Unlike clinical thermometers used for measuring body temperature, laboratory thermometers are designed for a wider range of temperatures and different substances. Let's look intro some of its features. Design. It typically consists of a long, narrow glass tube with a bulb at one end that contains a special liquid, like mercury or alcohol. Range. The scale on a laboratory thermometer can cover a wide range of temperatures, from very low like -10 degrees Celsius, to very high like 110 degrees Celsius or more. Application. Laboratory thermometers are used to measure the temperature of liquids, in beakers or flasks, gases, and even solid objects in controlled experiments. Handling. They may have a ground glass joint at the top for easy handling and attachment to laboratory apparatus. Importance of laboratory thermometer. Laboratory thermometers are crucial for conducting accurate scientific experiments and ensuring precise measurement of temperature-sensitive reactions and processes. They help scientists and researchers understand how temperature affects different substances and phenomena in chemistry, biology, and physics. The transfer of heat refers to the process by which heat energy moves from one object or substance to another. There are three main methods of heat transfer. Conduction. This occurs when heat moves through a material without the material itself moving. It happens in solids, where particles vibrate and transfer energy to neighboring particles. Let's look into some examples of conduction. Touching a hot pan. When you touch a hot pan on the stove, heat is transferred from the pan to your hand through conduction. Ironing clothes. The sole plate of an iron heats up due to electrical heating elements inside. When you press the iron onto clothes, heat is conducted from the iron to the fabric. Heating a metal spoon. When you place a metal spoon in a hot drink, the heat from the liquid is conducted through the spoon handle to your hand. Second method of heat transfer is convection. Convection is the transfer of heat through the movement of liquids or gases. When a fluid is heated, it becomes less dense and rises, while cooler, denser fluid sinks to replace it. This creates a circular motion that transfers heat. Let's look into some examples of convection. Boiling water. When water is heated in a kettle or pot on a stove, the hotter water near the bottom rises due to decreased density, and cooler water from the top moves downward. This circulation of water transfers heat throughout the pot, causing it to boil. Hot air balloon. A hot air balloon rises because of convection currents. The burner heats the air inside the balloon, making it less dense and causing it to rise. Third method of heat transfer is radiation. Radiation. Radiation is the transfer of heat energy through electromagnetic waves. Unlike conduction and convection, radiation does not require a medium and can occur through a vacuum. Some examples of radiations are sunlight. The sun emits electromagnetic radiation, including visible light and infrared radiation. Sunlight reaches the earth and heats its surface and atmosphere. Heat from a fire. The heat you feel when sitting near a fire or a hot object like a stove or heater is primarily due to infrared radiation emitted by the hot surface. Microwave oven. Microwave ovens use electromagnetic radiation, microwaves, to heat food. These microwaves penetrate the food and cause water molecules inside it to vibrate, generating heat. Sea breeze. Sea breeze is a wind that blows from the sea toward the land during the day. As the land becomes warmer, the air above it also gets heated and rises. During the daytime, the land heats up faster than the sea due to the sun's heat. It happens because of the temperature difference between the land and the sea. Sea breezes are usually felt in coastal areas during warm sunny days, bringing cooler air from the sea and providing relief from the heat. At the same time, the sea retains its cooler temperature because water heats up and cools down more slowly than land. This movement of air from the sea to the land is what we call sea breeze. The cooler air above the sea moves in to replace the rising warm air over the land. It's obvious if there is sea breeze, there must be land breeze too. Let's see about it. Land breeze is the opposite of sea breeze and occurs during the night. At night, the land cools down faster than the sea because it loses heat more quickly. As a result, the air above the land becomes cooler than the air above the sea. Cooler air over the land then sinks and moves towards the sea, displacing the warmer air above the sea. This movement of air from the land to the sea is known as land breeze. Land breezes are typically felt in coastal regions during the night, bringing cooler air from the land towards the sea. These breezes are natural phenomena influenced by the differential heating and cooling of land and water, impacting the local climate and weather patterns near coastlines. They are often weaker than sea breezes because the temperature difference between land and sea is usually smaller at night compared to daytime. We all know that we wear different types of clothes in summers and winters. Do you know why? Why can't we wear same clothes in all the season? Clothing in summers. Lightweight fabrics. In summer, we wear clothes made from fabrics like cotton and linen. These fabrics are light and breathable, which means they allow air to flow through and keep us cool. Bright colors. We prefer wearing light-colored clothes in summer because they reflect sunlight and don't absorb as much heat. This helps us feel cooler even when it's hot. Clothing in winters. Warm and thick fabrics. In winter, we wear clothes made from thick and warm fabrics like wool and fleece. These fabrics trap heat close to our body and keep us warm. Dark colors. Winter clothes are often dark-colored because dark colors absorb sunlight and keep us warmer. They help us feel cozy even when it's cold outside. Hope you enjoyed and gained knowledge about heat. We'll meet in the next chapter. Bye-bye and take care.